I know some of y'all have been filling them out as you go, which I appreciate. And I do recommend you get it fully filled out. The filled in one is currently on Schoology because of the fact that my seniors are getting ready to take their test tomorrow. Some quick reminders. When it comes to your postulate sheet, the front starts off with a vocab area, and then it talks about relationships between segments and arcs. Flip it over, it talks about the relationship between angles and arcs. And then on the bottom, there's something that's completely different. How can I tell if a picture has angles and arcs versus segments and arcs? Yesterday was all angles. How do I know that everything on here is either angles or arcs?
Just pointing to them or drawing?
It's pointing to them, that's part of it.
Normally arcs are outside the circle.
Arcs are generally outside the circle, I agree. Angles will often have a little swoop in a corner.
Point of tangency?
That technically has nothing to do with it. There is a point of tangency, but that's not going to tell you the difference between it having angles versus segments. Here's the key thing. What units are on all of the measurements on this entire page? Degrees. What things are measured in degrees? Angles and arcs. So, that tells you, when you see everything is in degrees, that tells you you should be looking at this part of your postulate sheet and trying to match up pictures. When I see this, I notice that this looks like technically sorry, I'm on the wrong side. Angle side. When I see this, which picture is it looking like? That one. When I see this, which picture is it looking like?
Bottom.
The bottom ones. Which there's 3 of the bottom ones, but these 3 all follow the same idea. This one. Which picture does it look like?
The one on the right.
That one. Sorry. I'm going to flip over. Now, we crossed off question 12, but for the sake of argument, which picture does this one look like?
One on the right.
The top right. So, matching up the pictures is hugely important, but also making sure you know if you're talking about angles and arcs or if you're talking about segments. Because today, we are going to be getting into segment relationships, specifically segment relationships that are going to start to look like pictures that we saw already. If you open up to page, I think it is 16? Are you sure it's 16? 18. 18 make more sense.
Oh,
Because we started yesterday on 15. If you open up to page 18, would you agree with me that this picture kind of looks like this one?
Yep.
But they're not going to use the same thing. Let's make it a little bit more clear by looking at a picture that actually has the measurements on it. This picture looks kind of like this one, doesn't it?
Yep. Nope. Actually, no.
Yeah, it does.
It's got the cross inside the circle, right? But do you see a single degree on this picture?
Nope.
No, indicating you're looking at a segment, which means I need to do what with my postulate sheet? Flip it over. And find the picture on this side that looks like it. This is the hardest part of chapter 10, is knowing which theorem to use. That's why we use the pictures, and that's why I am emphasizing to look for certain things, like degrees go with angles and arcs. If you don't see a degree symbol, it's talking about a segment. Now, today, we've got a whole one page we're talking about. Today was specifically designed to kind of back off a little bit and give you a little bit of time to kind of process some of the other stuff that we've been doing too. Today, much like you saw yesterday with angles, but today we're focusing in on the segments, we're going to have two chords going through the middle of our circle, particularly intersecting. When those two chords intersect within the circle, the chord gets divided into two parts, into two segments. They're not the same length as one another by any means. They are called segments of a chord. When you have segments of a chord, there is a relationship between the small parts of those chords. And it is that when we have these chords intersecting, the product, what is product? Operation. Add, subtract, multiply, or divide. I'm asking about product. Don't tell me product is sum. It's multiplication. So the multiplication of the lengths of those segments of the same chord is going to be equal to the product, the multiplication, of the lengths of the other chord. So, you may or may not want highlighters today. I'm going to do a little bit of highlighting, but most of my highlighting is really just going to be on the theorem itself. So, I've got 4 highlighters today. So if you want to grab some highlighters, go ahead. If you don't, it's not the end of the world. But this theorem says to take one of the segments from the chord and multiply it by the other segment of the same chord. What is the name of this segment? AE. So AE is going to get multiplied by what segment is in the same chord as AE? EB. AE gets multiplied by EB. And when you do that, you should get the exact same thing. It should be equal to, if you multiply, what's this one called? DE. By, what's this one called? EC. It is easy. It's just making sure you're not mixing things up. Okay. So, I'm going to get to our problems. First problem looks like this. Does this picture look like that picture? Yeah, it's got 2 chords intersecting. Double check. Am I working with segments or am I working with angles and arcs? How do you know these are segments and not angles and arcs? There's no degrees. That's the key thing. There's no degrees. So, that means I'm using this formula. It doesn't matter which segment you start with. You just got to make a choice. Which segment do you want to start with?
X times 3? Or wait, no. Yeah, X times 3.
X times. Does it get multiplied by 3? Is Colin correct on that the X goes by the 3? Are those on the same segment? Or on the same chord? Yes, so yes.
The X would be the AE, and then the 3 would be the EB in the example above.
They could be. Technically, it could be the other direction too.
Yeah.
X times 3 has got to be equal to what on the other side of the equation?
4 times 6.
4 times 6. What is X times 3?
3X.
What is 4 times 6?
24.
Divide by 3 and X is? is all it wanted was for me to solve for the variable? Yep.
Also round to the nearest hundred.
Yes, it also says round to the nearest hundredth if necessary.
Thank you for all that.
You're welcome. Clara can help.
Vivian, where would you like to start on the next problem?
X plus 1 times 2 equals 4 times
Good. But if I write it like this, I'm gonna have a problem. The theorem says I have to multiply complete segments. Which means when I multiply this x plus 1 times this 2, I have to multiply the entirety of x plus 1 times 2. Meaning, if you see something with a plus or a minus, in this formula, you will always need to put it in parentheses. Distribute. What do I get, Nate?
2x plus 2.
Yeah, exactly. You do know. While you're at it, what's 4 times 3?
Yeah.
You're welcome, Lee.
Y'all know how to solve this.
No, I don't.
Ava, how do you solve it?
You minus the 2, which you get 1, and then you divide by 2, and then x is 5.
Exactly. No, I don't. Psh. Just got yourself put on the spot on purpose. Okay. Greta. Now, one thing we didn't do on the last one that you should be doing on this one, before you jump into the theorem, you should double check we're going to use the right theorem. Greta, is the theorem up on the top of the page the correct theorem for this picture? How do you know?
because they both like line.
It's not a way to know. They do line up. I agree with you wholeheartedly. Like, the pictures line up. Like, the pictures look the same-ish. A little bit different, but that's not just the thing you need. You also need one more thing to tell you that you're using this theorem instead of this theorem. That would be unfair, given that you just walked in. I can't call on the kids that are out in the butt. Go for it, Isabel. There's no degrees. You gotta look to make sure you're not working with angles. If you're working with angles and arcs, the picture can look the same, but the problem is different. And on the test, on the review, it's all going to be mixed together. You have to recognize the difference. Yeah, on the notes, I'm not mixing it up, but it will be mixed up as we move forward. Charlie, what's the equation going to look like for this one?
14 times parentheses 13x plus 1 equals parentheses 10x plus 1 times 18.
Charlie put parentheses around two things. Did he have to do that?
Yes.
When do you have to put the parentheses?
If there's a plus or a minus before the
Just if there's pluses or minuses in these problems. If you're using this theorem, pluses or minuses, need parentheses. Yes, we are going to distribute. Kylie, can you tell me what you get when you distribute on the left side? I'm sorry, plus what? Beautiful. Bijou, what do we get when we distribute on the right side? Ooh, not 180 times 18, 180 x plus 18. Good. Don't forget your x's. Haley, how do we solve from here? Elena,
Minus 14.
Jasmine, how does it finish off? And you get? Exactly.
I got that answer.
I
Yeah,
don't
I
doubt
got
that.
answer.
That's today.
That's it.
Yes.
I like this.
Today is meant to be a short day.
Let's go.
It was designed this way to give you a chance to also work on some of your other assignments.
We love you, Miss Benson.
Oh, you hear Charlie with Benson?
No.
I don't know.
He's gotta go home.
Yeah, can Charlie go home?
At 3:20 you can.
We're all about to go home via flying out the window.
Oh. I don't think those windows open as Benson.
They don't. You don't think I can break one?
No, I don't think so.
Valid. I also wouldn't throw you out the window.